We've got Ben Lowry talking about offline first, not offline mode.
Hey everybody. Hearing you to talk about offline first, not offline mode, like Kara just said. If you don't have any idea what that might be related to, it's basically talking about applications that work offline. Now, it can be difficult to build an app that works offline. There are a bunch of challenges and stuff that we'll talk about as we go on, and obviously a lot of benefits that come with it, otherwise why would you bother? Right off the bat, I want to thank whichever DDD volunteer made this slide. It's really nice. The rest of the talk is more like this. Good old clicker fun. There we go. So, nice, plain. Don't expect the flashy stuff you just saw. So, I'll talk a little bit about me. I'm Ben Lowry, lead consultant at Telstra Purple. I've spoken at DDD a few times before. You may have seen me up there. Or if you're in Karen's talk just before this, I've featured pretty heavily in that, so you may recognize me there too. I want to thank the other sponsors. I know I thanked one particular volunteer. I don't actually know who it was, but everyone who's volunteered and all the sponsors who have gone into making today happen. It's a big deal, and the event doesn't happen without them. Cool, so an offline application. What is an offline application? Well, it's an application that works offline. That much is clear. We're going to talk about, why you'd want to build one, what benefits you get from doing it, and some of the challenges that come from that. In terms of how you'd actually do that, I'm not really going to get too much into specific libraries or frameworks. It's more general advice, mostly because there are a bunch of people here. You might all be using different tech, and a lot of this stuff is transferable, and if it went specific, it'd only work for 3 of you, let's say. So why might you want to build an offline app? A big one is if you have an app that needs to be used in remote areas. This is a map of 4G and 5G. If you look for the little purple bits, those are 5G. What coverage, basically, from Telstra. So I assume that's bigger than all the other ones, but I don't know. But there's still a lot of areas in Australia, particularly in WA, where you don't get any internet. So if you're working, building an app that needs to work, say, on a mine site or an oil rig or a remote community, like maybe you're building something for Water Corp or something and they need to go out in the field and use it, then there are a whole bunch of places where being offline but still being able to do your job is really important. Another one might be if you have internet outages. So this graph is basically a Cloudflare outage that happened in June. Basically, you can see for about an hour the internet traffic they were serving halved. Now, given that Cloudflare serve about 20% of the internet in general, that all of a sudden dropped to about 10. So 10% of the internet just didn't work. If you want to be resilient to that, and resilience is something we'll talk about quite a bit today, if you went to Derek's talk in here earlier, you probably have some useful tips already. I might give you a few more or a few slightly different views of that. But what the resiliency gives you is actually more than just when the whole internet goes down. You also get resiliency for things like if you don't have zero downtime deployments, or if you just have a bug in your code where you start returning 500s or a configuration error or something like that. It means that users can keep doing their work without worrying that it's not going anywhere. So you've had to build the app in a way that is resilient, but by doing that, you get a lot of benefits. The other one is just kind of situational lack of internet. So if anyone got the train here this morning, you may have gone through a tunnel and maybe your internet dropped out. Or I know for me personally, most of the days I go to work, as I'm leaving my house, I'll start scrolling through Spotify or something to find something to listen to. And then as I leave my house Wi-Fi, get into the world, I guess the 4G or whatever, then my internet cuts out and it always says, you're offline. And it's a little bit annoying that things don't work in that period. Other times, you want to go for hiking or something, you just find yourself in a situation where you don't have internet It's not really your fault. It's only going to be for a short time, but you just want to keep doing your job. Another reason you might want to have an offline app is for security or privacy reasons. So to use an example of something that's been in the news a little bit recently, in the US, they changed some laws around abortions, and there were recommendations going around to like delete period tracking apps and that kind of thing because the data gets stored in the cloud, and maybe they can go and, I don't know, like subpoena or whatever, one of those apps to get all that data, find out whatever they want to find out, I don't know, nefarious things. If the data never leaves the device, then you don't have to worry about it so much. I mean, they could still get your device, but it's more a targeted attack at that point. So, and then the final one that I've got here is that it's actually oftentimes a better experience for users. It might be faster because you don't have to wait for it to load all the time. You might use less battery or less network. So in like data-constrained environments, particularly in places like Africa or Southeast Asia or wherever, where data isn't cheap, that can be a benefit. You can do things on Wi-Fi and then go offline when you're not in Wi-Fi. So as an example of how much that's quicker, I have a colleague who worked on an app that has an offline mode, and they have a multi-step form. So at the top here, we've got the offline mode, and at the bottom, offline first application. Sorry, offline and then online. So the reason that it's faster is basically because when I click next, one of them goes straight to the next page, and the other one goes, cool, I'll save what you've just done, and then I'll take you to the next page. So without that spinner, things get a lot faster. And the example that this colleague gave me was that the offline mode took about 40 seconds to fill in this whole form, this multi-stage form or whatever. And the online one took 60 or 80 seconds or something like that. So you do get some benefits from having an app that works offline, just because it doesn't actually need to do as much. Now, every application is different, and there are going to be different kinds of offline applications as well. Some of them might need to go online periodically. Some of them might kind of have a fallback that works offline, and then others are going to have kind of the full functionality offline. It really does depend on what you want to build and what your kind of users' needs are. Like Spotify, for example, probably lets you download or your tracks to play offline, but you can't use the search function to go and find more stuff, for example. That's a compromise they've made, and that's just what works for them. So I like to think of it as layering up complexity. At the base level, you've kind of got an app that's only a read-only. Those are really easy to make work offline because you just download the data and leave it there. The next kind of level is when you have data that only stays on the device. It never actually gets any further. And those, again, they're pretty easy. You never need to talk to the network. Everything's fine. You might have some sort of caveats to those where, for example, they sync data to online when you choose to. So you can export and import kind of stuff. One of the reasons you might want to build one of these apps is because it's really important that the data is actually always available and it's always up to date. So if you know you're not getting it from a server somewhere, then what you've got on the device is actually perfect, right? It's the source of truth. That's where everything goes. But just because you're not online doesn't mean you can't have some of the same features that are online. So if we imagine like a first aid app where you can download first aid articles or something, then you go out into the bush and you get bit by a snake. So you open up your offline first aid application and you type into the search, snake bite. And then it goes, oh, you're offline, I can't return you any results. That's not a great experience, right? So you do still need some things to work. The next one is pretty classic, like graceful degradation scenario. You have an online app that works online, everything is editable, whatever, and then when you go offline, you lose some functionality. So you can't edit anymore, but you can still read all the data. To help you make decisions and stuff, it might be appropriate for whatever you're building. like an example could be a shopping list or something, where you can download a shared shopping list and see it, but you can't actually make changes. Maybe a bad example, but it's the kind of thing you could build. The next level would be where some data is editable, so you might only be able to create stuff, but you can't edit stuff that already exists. And then the last level of kind of complexity, and this is what we're going to focus most on for this talk, is those apps where just about everything works offline. Not everything can work offline, like you can't do video streaming or live chat or anything like that. But if you can do all of your job, you can go around editing things and deleting things and completing tasks or whatever, then that's a good step at least. So broadly speaking, you've got offline only and then mixed kind of offline and online apps. So I've got an idea. Let's add an offline mode to our app. Offline mode seems easy. So I've sold you on all the benefits, right? So let's go and do it. I've already got a to-do list app. How do I start? Well, the first thing is that you have to download your data to use when you're offline. So what does that actually mean? Downloading your data means essentially you're going to keep a local copy of that data, and then anytime you use the app, you just read from that local data. It's pretty easy. The other part of that will be that when you make changes, you need to sync them back up to the server. So there are a few ways you can do this. A lot of smart people have gone into the effort of actually deciding what that is. There's a thing called a CRDT, which is a conflict-free replicated data type. And the idea is that every kind of local copy of your database and the one on the server is actually kind of like a distributed system, and you just need to replicate changes across them. So all your cloud providers and stuff will probably handle this for you in terms of like, I've got a SQL database or a table storage or DynamoDB or something. But the way they actually do it is using these CRDTs. So there are three broad categories. One is operation-based, which is essentially like having a list of operations that you've done. So you might say, I've done a create task in my to-do list, and then you save that for later, and when you come back online, you process all of them and go from there. Another one is where you just update the local database you've got, and then have something that basically just sends that up to the server, something on the server that figures out what changed, and saves it. That sounds really cool, and there are some tools that do it, but I don't actually have much experience with those specifically. And then the other one is just the saving changes. So you get kind of databases that have, rather than storing the state of the thing, you just keep a list of changes and essentially you send those up to the server when you come back online. Now the one I'm going to talk most about is the queue, because I feel like that's the easiest for people to reason about. It's probably the entry level kind of offline mode. It's just doing what you were already doing, but saving it for later. So we'll have a little bit of a look at some code. There's not a lot of code here. Hopefully it's something you can reasonably understand, even if you don't write a lot of code. Basically, we have a to-do list, and we're going to say, if I'm online, then call the API to get the to-do. Otherwise, get it from my offline data, and then return that. So seems okay, right? If you're online, do this. If you're offline, do that. The same kind of approach for an update. If we're online, save that to the API. If we're offline, then update the local storage and queue the update, essentially. So we can kind of generalize that to say we've got an app that when you're online goes from A to B, it does X, right? If you want to talk about offline mode, that's saying if you're online, do X. If you're offline, do Y. Right? It's not impossible. It's actually not that hard. But what's the problem with it? Well, firstly, having two ways of doing things means that you have to make sure both ways work. You might forget to do one of them. Like, have you worked on an app with an offline mode where someone goes, oh, yeah, that's done. I just need to make it work in offline mode? Or, like I said, how many of you have forgotten to make a particular feature work offline? So there's got to be a better way. And that way is to build an offline first app. So rather than going from the mindset where I have an app that I want to work offline, you say, I've got an offline application, how do I make it work online? Basically, you're starting from the assumption that there is no internet and working up from there. Now, this comes with a lot of benefits. Like I've already talked about, the biggest one is that it's actually simpler to reason about when you've got one way of doing things. So rather than saving to the API or queuing it for later, you basically just always queue it for later. And then you have a background process that saves into the API later, which you would have already had anyway to handle offline mode. So probably the biggest difference between an offline first app and an offline mode app is that you're not treating being offline as an error condition. It's not a special case you need to handle, it's just how it works. Now, I mentioned the term graceful degradation before. That's basically saying, I've got an app that's good, and when it's offline, it can be almost as good. The other way to look at it, which is what offline first is saying that it's a progressive enhancement. So rather than having something that gets worse, you actually have something that gets better. So you build a good offline app, and when it's online, you enhance it with other things. That might be that when you go to edit a particular item, like in your to-do list, you go load the to-do list from the cache, and then, hey, I'm online, so I might as well go fetch it and get the new stuff. So we'll go through that little bit of code again, and we'll try and change it from offline mode to offline first. Now, I said the big problem was if this, else that. How about we get rid of the else, and we'll see what happens. It's gone, easy. So now we have an online app that fetches the data, and then we return the offline data. We've actually missed one little bit in here, so I'll make room for that. And that's basically when we get the new data, we have to update the offline cache as well. Now that's done, we can tidy up the code a little bit, get rid of some variables, because who likes variables? And the code's pretty simple. If you're online, do this, and then always return the offline data. I mentioned before that waiting for things actually makes it slower. So you can see these async and await words. If you're not familiar, async just says that you can use the await keyword, and the await keyword just actually waits for it. So the program will stop and wait for that thing to respond. If we just get rid of that, it no longer waits for that response. So we don't have that issue where it's slower because you're online. Now, whether or not you can actually do this is going to depend on probably a framework or something that you're using. In React, you might write a hook that abstracts that away. That's primarily what I write, so I don't know all the others exactly, but other reactive frameworks like Swift UI or Reactive UI or Svelte, I assume have similar concepts, right, where you can just update this behind the scenes and then show the new version. We can look at our update as well, and we go, now we've got that if-else, but we'll tackle it slightly differently. Instead of relying on updating this thing as it's happening, we've already built a robust solution to handle those background updates, and the robustness of that is very important. We'll talk more about that later. So why not just use that? We can get rid of this whole section entirely, and we're left with something pretty simple, right? We update the offline data, and then we schedule the update for later. This idea of updating the offline data is actually really interesting. Has anyone heard of optimistic UI or optimistic updates? A couple of people. So that's the idea, basically, that because it feels slow to wait all the time, let's just update this thing with the expectation that it works. Now that is something that happens in online apps as well. It's kind of essential in an offline app because otherwise you're always looking at old data. But online apps do this as well to try and feel faster. They basically want that offline experience where things just work, you know? So there are lots of tools now to go and do those optimistic updates. They get built into query libraries like Apollo Client or React Query or things like that. Again, I mainly work in React, so those are my examples. So I've painted a pretty rosy picture about how easy it is to make an offline app. And there are a bunch of challenges. We're going to talk about them a fair bit after I've had a drink. So when you talk about offline apps, one of the big challenges that people will raise is the idea of getting a merge conflict. Now, developers are pretty familiar with merge conflicts because we get them all the time when we're writing code. And you won't find many people in the room who actually enjoy that process. But it's not necessarily as big a deal as people think it is with an offline app. So I'll just run through a little bit of what a merge conflict is, because it's a complicated idea if you're not familiar. Basically, a merge conflict happens when two people change the same thing around the same time. So in this case, we've got Alice and Bob. Alice opens a thing, saves her changes, and in that in-between phase, Bob has also opened the thing, and he saved some changes. Now, when you get to the end, if they've made different changes, you need to figure out what to do, essentially. So there's kind of an important line we can draw in the sand, which is when that first person saves it, the person who goes after that will get a problem. Now, I've got the lines roughly in this kind of range, but really they can be anywhere. Essentially, if you open it before that dotted blue line and you save it after that dotted blue line, then you have a problem. If you open it and save it before, the other person gets the problem. If you open it after, then you're already getting the latest updates anyway. So you're not going to get that merge conflict scenario. The thing is, for an offline app, it's not so much about when you open it and when you save it. It's more like when you were last online to get the version at the beginning, and then when you come back online at the end. So the time frame for actually getting a merge conflict when you have an offline app is quite a lot bigger. But the problem is existing no matter what. Even if you've got a thing that takes 10 seconds to fill out, there's still a 10-second window where someone might open it and hit this problem. So you already do something about merge conflicts. You probably just haven't thought about it. Common things that you might find there would be that the last update wins because they made the change last, so just overwrite whatever was in there with what they put. Hopefully, some of the changes would be the same, so it actually doesn't matter if that happened or not. But there are other approaches you can use where rather than say, hey, here's this whole thing, here's a title and a description and some tags on our to-do, go and replace whatever was there. You could actually just say, all right, you changed the description, so let's update the description. And that limits the amount of merge conflicts you'll get. And the idea behind that is kind of like a patch operation. There's a HTTP patch keyword and a RFC and all this fun stuff around that. But basically, merge conflicts are a problem, and you do need to think about them, but they're already a problem. So going offline doesn't really change it, except that you might hit it more. Another one is API versioning and backwards compatibility and those kind of concerns. Because you may have had an app that was last online 3 weeks ago, if you've changed the API in that 3-week period and done a breaking change, then anyone who comes back online from 3 weeks ago, the things they're trying to do won't work because there might be missing required fields or that kind of thing, right? So it becomes more important that you accept backwards compatible, like old versions of stuff. So I don't know, you add a new field to your to-do that's called assignee or something. And then if you make it a required field, anyone who doesn't provide an assignee, it'll fail. That's kind of a problem, right? So you still need a way for someone to do their job without that field. And a common approach to that is having API versioning. There are a bunch of other ways as well, but again, that's going to depend on how your app works. You'll notice a common theme around these, that they're all related to handling errors, because when everything works and everything's easy. The problem is when there are problems. So another one is things like field validation. If you have a required field that you've added, whether it existed before or exists later, essentially, if you rely on the server to validate these requests that you're making before, rather than letting the client do it, that means your offline user has to wait potentially weeks until they actually try and do the thing, and then it fails. So that's a problem, because to go and add a required field when you press submit is pretty easy, right? But if you're revisiting it weeks, days, hours even later, it's a lot harder to know what the right thing to put in there is. So I talked about the offline queue, or the queue of changes to make. So we've got a little animation thing that I'm pretty proud of that I made here, basically showing that process. So this little box is going to be our magical processor, and all the little rectangles are the things we're going to do with them. So we start by processing one, and we take the next one, process that, take the next one, and it's failed. So if you went to Derek's talk earlier, he talked a lot about retries and timeouts and exponential backoff and those kind of things. And yeah, you probably do want to retry these requests, because they might just be intermittent errors. If they're not intermittent errors, then you retry it and it will always fail. So what do? If you talk about a queue, then there's this idea that you process them in the order they came in, but this one is now stuck. So you need something to essentially put that aside, and then you can continue processing the rest of them. Now, you're not done yet. That one that you didn't process is still valid. It's still something that someone tried to do and it didn't work. So you need a way for them to resume that. It'll depend on, again, what the app is and what you expect it to do. But basically, we need to try and reprocess it again in a different way. So that might be saying you can go back in and edit and try again, or you save it to some API and get an admin team to process them, or you just roll it back and say, hey, sorry, we couldn't do that, throw it away. Again, depends on what your data is. But the kind of robustness of this process is really important, because it's core to your app now. So whereas before in offline mode, it may have been there and you didn't spend all of your effort building it, maybe you get some problems and it's sort of okay because when they're online it works. But for an offline first app, this is the only way you get those updates happening. So again, make it robust. You need to think about things like having an item potency on your requests. For example, if this was a delete that failed because the thing was already deleted, you could go, well, you're trying to delete it and it's deleted, so it's fine, and just mark it as successful, basically. And you might also have dependent requests in here. So let's say this was a create, and then later I had an update. That update would also fail because it's got nothing to update now. So you might find that you get a few of these things happening. Another problem is when you have a patchy internet connection or an unreliable connection rather than being just offline. That's actually kind of worse. You could look at the things like on your device, they often have indicators that say whether you're online or offline. But how reliable are they actually? You might want to put in something like a health check endpoint on your API where you can call that to see, the device says I'm online, but can I actually call the APIs that I need to call? And then, base it on that. you might want to consider having the app like manually try and sync up rather than doing it automatically, so the user can say, yeah, I want to sync now. Again, that doesn't work for everyone, but it's an approach that you could take to handle this problem. So rather than just responding to being online, you can wait until the person is like, yeah, I'm back in the office now, so I can do this thing and it should work. Another thing is when you have an offline app, you probably need to tell your users that it's offline, and you could say something like, you're offline. But do they know what that actually means? So rather than just say, you're offline, you might want to change it up a little and say something like, you're offline. Changes will be saved when you're back online. That kind of hints that, oh, I'm not done just because I think I'm done. There's something else I'll need to do. Again, you talk to whoever about the exact wording there, but there's that kind of idea where telling them what the state is doesn't help, tell them what they can do about it. And then as you go through, you might say, we've got 3 changes pending upload, or we've uploaded 5 of 8 of your changes, or all changes are saved at the end. Just to help the users understand that, yes, you're offline, and what does it mean for you now? Are you done yet? When you get this kind of message, it's like, oh, cool, everything I've saved, everything I've changed has been saved, so I can go about my day. Everything's normal. Another one that will be affected by having an offline app is that the security posture of your app changes. Because you're getting all this data onto your device, it's potential that someone else could get that data off the device. So you might want to think about things like encryption, if that's important. If you do have encryption, then where do you store the encryption keys? If they're also on the device, then it might be a little, pointless to have the keys stored with the data. So you think about how that's going to work for you. Another big one is if you have shared devices, let's say in a workplace, it might be there's a kiosk thing that people use to do a job. And when someone's shift ends, they hand it over to someone else, and they'll go do their job too. So if there's kind of user data on there, you might need to think about keeping it separate from the other user's data. It's going to depend, right? Maybe it's fine for them to see it. Maybe it's not really user sensitive. But if you're storing, their name or date of birth or something somewhere, then, you might want to hide it as well. So that's where encryption would come in and all the other fun things. And then another kind of complicated issue is that most of the apps that we build, especially if you're going for enterprise kind of clients or whatever, you'll need some kind of authorization and authentication, some like login stuff. Now, when you're online, you can log in and get refresh tokens and have a token lifetime that lasts an hour, and then you go and get a refreshed version every hour so that you don't never run out, right? If you're offline, you can't do that anymore, so you might need to think about how you need to relax those rules or those guidelines just to handle that scenario. So you might let people in if their token has expired, and maybe only for a certain amount of time, but it's probably something you need. Otherwise, they can't go offline for more than an hour, right? So it would depend, again, I'm a consultant, so it always depends. But if you think about what it means for you, maybe you let people in, and then before you actually save anything, you do go and get that new token so that it all works. But that's the sort of thing you need to think about. Another one I've got another challenge is if you want to build an offline web app. So you could have like a mobile app which has its own challenges potentially, but a web app is probably even bigger because the convention is that you would download everything essentially every time you visit the app. You might have caching of style sheets and stuff through your CDN, But if you're going to have a fully offline app, you need to have that data saved on the device always. So there are things to help you with that now. Like if you build a progressive web app, a PWA, then you get a lot of that stuff built in. You have a service worker, download all the assets, save it for later, right? It's not impossible, but it is a little bit more difficult probably than a native app, because native apps let you download all that stuff ahead of time anyway. You know, you download your app from the App Store, and it's 50 megabytes or whatever it is, and all the stuff that you need there is included. Whereas on the web, you download that every time. And then the last sort of challenge that I've got to cover, I guess, is those features that just won't work. So, you know, this is video streaming, right? That's not going to work. You can't build Teams or Zoom if you're going for an offline app. Those features just won't work. So there are limits. Now, we've talked a bunch about the benefits and the challenges that have come with this. We talked about why you might want to build one. So if you want to be used in remote areas or just in situational offline times, you know, someone's probably got a Wi-Fi only tablet or something. If you wanted to bring that here and it didn't work because you didn't connect to the venue Wi-Fi, or the venue Wi-Fi was bad, then you'd have a bad time. And the benefits, I guess, are that you get a better experience for users. They can use your app in more ways, in more places. And yeah, we had to acknowledge that there are challenges with that. So I'm not saying it's easier to build an offline app than an online one. But if you think that you're going to build an offline app, or you know you're going to build an offline app, or even if you just want to build an offline app, then it's definitely easier to adopt that offline first mindset and treat it as the normal rather than trying to handle it later. You know, it's easier to know upfront what you're building and build it from the beginning. So that's all I've got today. I didn't think I would have time for questions, but I think I actually do. So if anyone does have a couple, thank you. Anybody? If not, you can go get lunch. Yes, hello. I don't know if there's a mic, but call it out and I'll repeat.
Yeah, so you said about encrypting data client side. I guess I just wanted to hear a little bit more about how that might work.
Cool. So the question was, how do you encrypt data on the client side? So there are many ways to encrypt. Let's assume you've got like a public-private key pair or something, which is a pretty standard way to do it. You would essentially probably, rather than getting the data on your device, you would download it in an encrypted format, I would expect, and then have something on your device to decrypt it. So if you have a private public key, for example, the private key can stay on the server, public key on your device. The way those two things work is that anything encrypted by the private key can be decrypted by the public key, and you can verify that that's where it came from. So that does kind of give you that option to download the data. If you're going to do something like encryption, that will probably dramatically slow down the app because you'll have to decrypt it all the time, and there are going to be gaps where it's in memory and stuff. So when they talk about those kind of hacks, like I'm trying to think of the names of them, but they have all these memory overflow, like buffer overflow attacks and stuff, you're probably still going to be vulnerable to that kind of stuff. It's not a perfect solution, but there's something there, right? Cool. Another one. Yep. Yeah, so when we stopped waiting for the response and we just kind of updated it in the background, Yeah, like you said, you would get your stale data first, and then you'd replace it with the new data when it came in. So it wouldn't always have changed, and you might see no difference. But yeah, if it did change, you'd have to handle that. So again, that's going to depend how you want to handle it. If you're okay with it being, initially stale data and then getting the updated data. I guess if you don't fetch that data, then you would always get the stale one. So. Yeah, so the idea being that if you kind of do that process where you update it after the fact and there's stale data, does it always make sense to do that? So, yeah. So something like, let's say in the top right, you've got a user avatar or something, right? If that just updates randomly, it doesn't matter. If you've just clicked to open something and that updates later, like you said, it might be jarring where everything changes on them. You'll have to decide what works for you. Potentially, you could just update lists of things like that. So you see the old list first, and then the new one loads in. There are kind of balances, I guess. It depends, but I hate to say that all the time, but it generally does depend. Cool, one more maybe? Hello. Aish, sorry.
What are your thoughts on hardware or device requirements for apps that are both online and offline?
I don't have any particular thoughts on that, I guess. If it's capable of being offline, which is everything, right? They've all got an airplane mode.
What about like storing data, large amounts of
Yeah, okay, yep. So I guess it's something I was probably meant to talk about but didn't. If you're going to download gigabytes of data, then you're probably going to have a bad time because it's all going to be on the device. So think about maybe only load the last month of data or something like that. You don't necessarily need everything from history. You might just need stuff that's relevant to do your job today while you're offline. So it could be a very small set, or it could be quite a large set of things that you actually need to download. Cool. All right, I think we're probably done. It's lunch next, so I'll wait up there, and if you have more questions, come see me. Otherwise, enjoy your food.